Welcome back. This is part 2 of your notes for chapter 1.7, Solving Inequalities. So prior, we were dealing with quadratics. Took everything and put it to one side because that way you can use the zero product property to solve. It's going to be the same idea here with rational functions. So I want this to be 0. So I'm going to bring 1 over to the other side. And since it's a positive 1, we're subtracting it technically. Now we need a common denominator. So technically it's over 1. And we need a common denominator so we can put these two together. So our common denominator is going to be x minus 3, since this one is x minus 3 and this is just 1. And whatever I do to the bottom, I have to do to the top. So how do I get from 1 to x minus 3? I multiply by an x minus 3. And be careful, you're subtracting every term within this quantity. Okay. When is it greater than 0? And what's going to happen here is this is just going to be 2 over x minus 3 is greater than 0. So we need to get what's called our critical numbers, just like we did for up here. The numbers were critical for x minus 2 and x minus 1 was 2 and 1, because when I substitute 2 and 1 back in, it becomes 0. Or there's a change in the graph. The hard part is you've never seen graphs of rational functions. If you look, let's try it. This is a graphing calculator. We're not using these in class because this one's like from the 90s. If you were to grab a graphing calculator from today, it can do just everything for you, and it'd be really easy to cheat. So we're not allowing these. And we're teaching you the algebraic methods versus the calculator methods. So I always tell students, like, if you want to go on the internet and just type in what the graph would look like, that might be beneficial. But we're going to talk about what these graphs are all going to look like. Okay, this isn't the best graph, so we're going to change our window. We're going to make our Wyman this. Try it again. Let's try this again. Oh, that was the wrong way. Okay, so like, see how small that is? It's actually going to be, try negative 200. Okay, you can't really tell. I don't want to keep dealing with window settings, but the graph's going to be kind of like this and like this. These numbers are so, the range is from negative 200 to 200. Let's try a smaller range. Yeah, you start to see it. So the graph kind of goes down and the graph kind of goes up. And this line down here is actually an invisible line, but this line's a representation of it, where your graph starts to be undefined. So where do you think this graph is undefined at? 1, 2, 3. Oh, at 3, bad things start happening, or weird things start happening to your graph. Why at 3? Because if you put 3 in, 3 minus 3 is 0. And can you divide by 0? No. So how do you find your critical numbers without having to do all of this? Algebraically, you look and you say, okay, I have a rational function, and something crazy happens when my denominator becomes a 0. So when will my denominator become a 0? When will my denominator become a 0? When x is 3. Okay, if x is 3, then that's not good. So this is called your critical number. So that's where you're going to get your intervals from. So you're going to have from negative infinity to 3, and then from 3 to infinity. So just like on the graph, from negative infinity until 3, what's happening? And from 3 on, what's happening? And since it's just greater than, we're not going to actually touch the number 3. So it can be brackets. So which interval is it? We want to know when we're greater than 0. You could go and look back on that graph when you're greater than 0, and it's obviously going to be when we're greater than 3, but you can just check algebraically. So it's graphically checking, but we want you to algebraically check. So a number between negative infinity and 3 is 0. You can pick any number you want. I like 0 because it's just nice and clean. So if I put here 2 over 0 minus 3, is that greater than 0? No, it's not greater than 0, so it's not this one. Well, yeah, this is less than, so yeah, it's not that. All right, between 3 and infinity, you can't use 3 because you have to be greater than it. So let's use 4. So, sorry, I'm doing this one-handed. So if I use 4, and put 4 in here, 2 over 4 minus 3 is greater than 0. Does 2 over 1, is that greater than 0? Absolutely. So this is your answer. So what this is saying is any number greater than 3 all the way to infinity, if I use it in this rational function, it will be greater than 1. And you can test it here or you can test it here. It doesn't matter. So this is your final answer. Okay. Next page. Same thing. Okay. Bring 3 to the other side. Now we need a common denominator. What did I do wrong? Well, this would be a common denominator, but what I do to the bottom, I must do the top. So you also have to multiply the top by x plus 2 as well. I'll put 0 down there. Okay, so going over here, x plus 12. That's technically a negative 3, and then you times x. You can distribute the 3 and then distribute the negative, but let's just do it all in one fell swoop. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. All over x plus 2 is greater than or equal to 0. So we have negative 2x plus 6 over x plus 2 is greater than or equal to 0. Now we're going to do this again. We need our critical numbers. Where does the graph change above and below 0? So we look at the denominator. When will this denominator equal 0? Because we saw before with the graphing calculator that that's when our critical numbers appear, so negative 2. But however, the numerator could also equal 0. 0 divided by anything will give you 0. Why didn't we do that before? Because your numerator was never going to be 0. Your numerator here is 2. 2 divided by anything will never give you 0. However, if I replace this x with something, I could get a 0. So when you do these critical numbers, you have to not only use the denominator, but you have to check the numerator. We didn't have to before because we would have never gotten 0 with a positive numerator like that. And not just because it's positive, it's because it was just a constant. So when will this equal 0? When x is 3. All right, so you pick the lower number. Your intervals are going to be negative infinity to negative 2, negative 2 to 3, 3 to infinity. Now, you can be equal to, so make these brackets. The hard part here is if you used negative 2 and it worked, then if you use negative 2 here, it's also going to work. So you want something in between. Okay, so let's pick like negative 3. You can go back to the very beginning if you want. So if I pick negative 3 and I substitute it in, negative 3 plus 12 is 9. Negative 3 plus 1 is negative 1, greater than or equal to 3. So is negative 9 greater than or equal to 3? No. So this interval will not work. Does this interval work? Is there a number between negative 2 to 3 that's going to be easy to use? Yeah, 0. You can use any number you want. If I put 0 back into the original equation, or any one of these equations, it should work. Please refocus. Thank you. If I put 0 in, I'll get 12 divided by 2, which is 6. So 0 plus 12, 0 plus 2, 12 divided by 2 is 6. Is 6 greater than 3? Yes, it is. So this interval works. 3 to infinity. Usually it's every other, so I'm probably going to say this isn't going to work, but let's try it. Let's try 4. If I put 4 into that equation, 4 plus 12 is 16. 4 plus 2 is 6. Is that greater than or equal to 3? Well, 6 divided by 6 That's going to be 2 point something. So no, that doesn't work. So yes, this is your answer, between -2 and 3 including. All right. Now, this is kind of randomly thrown in, but they start talking about domains. So we're going to switch gears here. Give yourself a minute. If you want to practice some of these in your homework, I would pause and do that. And once you feel comfortable, come back to the video and try this new topic. Okay. Domain is talking about your x values, not just an x value you use, but what's allowed to be in this equation. So am I allowed to use 5 in this equation? Will it work? Am I allowed to use 3,000, -27? So domain is what is going to be allowed in this expression or equation, etc. So domains are usually all real numbers. Domains are usually all real numbers because you usually can plug any number in and something will come out. But we're talking about square roots here or radicals. Like I said, this is randomly thrown in the chapter. Just roll with it. So if I take the square root of 25, is that okay? Yeah. What will we get? 5. If I take the square root of 0, what do I get? 0. If I take the square root of -25, what do I get? Some people say 5, no. Some people say -5, no. -5 times -5 is +25. Can you take the square root of -25? Let's ask my calculator, because I'm a bit confused. That's fine. Non-real answer. So I can't use negatives. So whenever I try to find the domain, I'm like, do positives work? Does 0 work? Does negatives work? I kind of ask myself that. So this has to be positive. So it's called the radicand. The radicand has to be greater than or equal to 0. So same thing here. When we find the domain, we're saying, hey, this has got to be greater than or equal to 0. So we're going to move 12 to the other side. We're going to divide by 3. Oh, when I take the square root of both sides, I'm going to get 2 and -2. But wait, we're not solving. We're not saying equals. We're using inequalities. And this is why it's randomly placed in here, because when there's inequalities, we just are solving for critical numbers and have to use intervals. So you take your lower number. This is equal to, so it can be a bracket. Then you take your lower number to your next number, or that next number to infinity. And you say, okay, which one does it work? I always start with, let's just start from the beginning. Okay, so pick a number. Let's try -3. Will -3 work? If I substitute -3 into here, -3 squared is 9. 9 times 3 is 27. So does 12 minus 27 work? No, you'll get a negative number. The square root of negative anything won't work. So X that one out. This one will probably work then. A number between -2 and 2 is 0. Okay. The 0 works. So let's go back up to our equation, or expression, I'm sorry. And if I put 0 in, 0 times 0 is 0. 0 times 3 is 0. The square root of 12 minus 0 is square root of 12. That's okay. That's good. So that works. Let's try plugging 3 in. Well, it'd be the same thing as if we plugged in or substituted -3. 3 squared is +9 still. 9 times 3 is 27. So this one doesn't work either. So this is your domain. That means only the number